Assalamu alaikum.
السلام ورحمة الله وبركاته.
السلام ورحمة الله.
Okay, I think last time we are doing this example. This is, as I told you, is a very good example from examination point of view. We say use a quadratic Lagrange interpolating polynomial by selecting the best 3 points from on the function defined by this one to estimate the cube root of 3 by 2. Cube root of 3 by 2 means 3 by 2 power 1 by 3. And then you say compute the error bound or absolute error. So first things we have to do now, as I told you the last time, we have to select what is your x given here. This is because we are doing chapter number 4, and in chapter number 4 we have to find the approximation of the function at the given point here. So what does this mean? This means your exact solution, and this means this is your function at the given point. And this is a function at x. So you can easily find out here x plus 1 equal to 3 by 2. What is 3 by 2 mean? 1 point? So 5. And this means you can get x is equal to 1.5 minus 1, which is 0.5. So now when you know the x, now you can easily find out the best 3 possible points, x0, x1, and x2. You have to select such 3 points because we are given 5 points here, please. So you have to select the best 3 points which should be close each other, and the point must be inside interpolating point, which is x is equal to 0.5 here. So it means the best point you can choose only R, 0, 1, and the 2 we have here now. So these are the information. Now we are ready to use a quadratic polynomial. The first thing you have to write the formula of the quadratic polynomial. This is a formula of the quadratic polynomial. And then this, we have to calculate the approximation of the function at given point 0.5. So it means you have this one, and we need f of x naught. What is f of x naught? F of x naught is the 0. So you can easily find out the f of x naught is what? Because you put just x is equal to 0. So 1 power 1 by 3, which is 1 here. What is f of 1? So you can easily find f of 1 from here. 1 plus 1, 2 power 1 by 3. And f of 2, which is 2 plus 1, 3 power 1 by 3. This means the only things you need to calculate L0 0.5, L1 0.5, and L2 0.5. And you already know the formula. And when you simplify, inshallah, you will get that one. Before you use a value of L0, L1, and L2 in the main formula, you can select, you can check the sum of the L0, L1, L2 should be equal to 1. If not, it means you have to recheck the value of the L0, L1, and L2. But when you this L0 plus L1 and L2, you can see easily is a 1. So you can put this value here in the formula. So you got everything now, and when you do, you will get the approximation of the function at the given point. We finished the first part here now. So what is next one? He say the compute the error bound, and error bound formula is this one. This is error bound formula for the quadratic case, and we don't know eta. Therefore, we take the maximum value of the third derivative inside the interval. So you are given function, and you can easily find out the first 3 derivative of the function. The first derivative of the function is this, second is this one, and the third derivative is very simple to find the derivative here. And then you find out the maximum value of the derivative, third derivative inside the given interval. Your interval is what? From 0 to the 2 here. So when you have the value, this one, if you have a function with the power negative Always remember that one, the maximum majhul at the smallest point here is 0. If the power is positive, maximum majhul at the largest point, but here negative, it's mean maximum majhul at 0. So 0 plus 1 mean 1, 1 power this one, 1. So we have a maximum value of the third derivative inside the interval is a 10 by 20. So put the value here, every information we already know. This is the things. Value of m we have. 3 factorial always means 6. So we can put in place of x is a 0.5, x naught is 0, and 0.51 and 0.52. And when you calculate, inshallah, you will get, this is the possible, what you call the maximum error or the error bound for the given approximation of the function. And the last part is compute the error bound, absolute error. And absolute error, you can easily find out what is your exact. It is 3 by 2 power 1 by 3 or 1.5 power 1 3. This is your exact. And this approximation you just find out in the previous step here, 1.1396 here. And the value of the 1.5 power 1 by 3, you can easily calculate by calculator, which is this one. And then you take the difference between. This is a maximum error. So this is a very good question we have here now from examination point of view, because all the trick teacher can give you, possible trick can give you, he give here, he give you the 5 points. And of course, then teacher want to see that how you select the best 3 points, because you have to use a quadratic polynomial. And the other things here, you are not given interpolating point directly. So you have to find out by yourself, which I give you the rule that this is the value of the function at any x, but this is the value of the function at given x. So that's, you can see here the power 1 by 3, 1 by 3. So it's mean in place of x plus 1, what we have 3 by 2. And then you can easily find out the value of this one. So that's a possible trick we can have here in the case of this example. Very good example from examination point of view. This is 2-3 times I also give in the exam this example. And you say that your function is this one and your x value are given 0, 0 0.2, 0 0.4, 0 0.6, and 0 0.5. 1, 2, 3, 4, 5 points here. 5 point mean degree 4. And he said that the question is given if the approximation of sine 0.28 by 4 degree Lagrange polynomial is this one. You don't have to find the approximation of this function at 0.28 with the help of 4 degree polynomial. It will be very lengthy, but it is already given by the teacher. What teacher want from you? He said compute the error bound and the absolute error. So we know what is the error bound formula for degree. This is the most important things you have here now. This formula you should know. If you have a degree 4, you must have a 5 derivative, 5 factorial, and 5 term. If you have a degree 3, you have a 4 derivative, a 4 factorial, you have a 4 term. So this is the things to memorize here now. So it means you need to find the value of m. M is what the maximum value of the 5th derivative of the function is the given interval, 5 factorial, and rest is the value. Everything is given here. X is given 0.28, x naught, x1, x2, x3, x4 given directly from here now from the teacher. So only things you calculate is this one. And when you find the 5th derivative of the function is a very simple function given sine x. 5th derivative of the sine x is cosine x. And then the maximum you at 0, which is 1 here. And you have the value of m, which is 1. 5 factorial mean 120. Then you have x minus x naught. X is 0.28. X naught is a 0. So we can have this one. Put the value, all possible value. And you will get a very good error bound. Should be very good. Very small value of the answer. Why? Because we are using degree 4. As I told you, as a higher degree we use to approximate or find error bound, jawab should be very good we have here. And then last part of the question, he said that find the absolute error. This is your exact, which is sine 0.2. You can use calculator. Generally, we use radian. Otherwise, if teacher need from you degree, he will mention in the question. And this is P4.28. Approximation already given by the teacher is no need to calculate here. And this is a possible absolute error we have here. So as I told you, please, in exam, if teacher need to approximation of the function, he must give you degree 1 or degree 2. But when he need error bound, he can give you the higher degree 3, 4, 5, 6, 7, whatever the things we have here now. And if it is the degree 5 mean we need 6 derivative and 6 factorial and 6 terms we have. The only difficulty thing is how to find 6 derivative, but your function given very simple, like this one, sine x. 6 derivative of sine is what? Is a minus sine x. And if the trigonometric function is not given like that one, he give you, for example, last time I gave f of x is equal to ex. What is the 6 derivative of ex? 6 derivative of ex is exactly the same thing. So only teacher want to check that how can you use the formula for the given condition. This is no need for that one here. Because this is a cubic polynomial, degree 3 we have here now. That's the teacher can give you also if you want to give you example like this is also good example. He say consider the following table we have. How many points we have? Is a 4 point. And then he say find the approximation of 0.45 using the best quadratic polynomial. And quadratic polynomial need always 3 points. So we have to select 3 points. How to select 3 points? Straightforward teacher give you the what you call x, which is 0.45. 0.45 is where? Is here. So it means the best point we have to use is this one. 0.2. This is your x0. This is your x1. And this is your x2. And now things become very simple. You write the formula, quadratic, write the formula for L0, L1, and this one. And when you write this one, everything is finished. You find the polynomial. After putting the value here, you know what is f of x0. I like this one. And when you have this value, so you can have quadratic polynomial. Now, when you simplify, make the coefficient of x square, x, and constant separate. This is a quadratic polynomial you get. And use this quadratic polynomial to find the approximation at 0.5. So only in place of x, you have to put 0.45, and inshallah, you will get. This is the approximation. And the second part is the same thing, error bound and the absolute error. We already know the error bound formula for quadratic case is this one. So you need to find the third derivative, which is this one. And you find the maximum value of the third derivative inside the interval. What is your interval from 0.2 to 0.5? So you just calculate the third derivative at 0.2, which is this one, and at 0.5, you got this one. So we have to choose a maximum value of the derivative inside the interval, which is this one. So this is the value of the m we have. Then you can put m, put here x, which is 0.45, x0 is 0.2, and x1 is what? What is the x1 given? Is a 0.4, and x2 is a 0.5. Use this value, and then you can have this one. And this is the possible error bound you have here. This is the things we have for the case of this problem, please. No need for this example. Now we do this. You remember that one here. I told you in the beginning of these, or starting of the chapter 4, that we are using two formula, Lagrange and Newton interpolating formula, to find the approximation of the function at the given point. And our data points we always need for the case of the chapter number 4. Data point mean when I say that we can choose from the x value. The x value may be given equally spaced or unequally spaced here. So as I say, Lagrange and Newton polynomial can be used if your data points are equally spaced or unequally spaced. When I say data points, I mean here the x values. So here I'm giving you the error bound formula for the equally spaced point here. And equally spaced point, how can you find h mean the distance between this one, between the points, and that should be equally spaced. So what is the formula? As I know, h, if you remember in 106 you did that one, I think it is what, the final point minus initial point taxim by n. This is a formula to find the equally spaced distance between the points we have here now. X naught is the final point, x naught is the initial point, n is the degree of the polynomial. For example, if teacher give you equally spaced data point inside the interval, then teacher never mention you the points, teacher only give you the interval. For example, we are given interval 2 and 3. Okay. And teacher can ask you degree 1, degree 2, degree 3, degree 4, degree 5. For example, degree 1. How many points we need, please? X naught and x1. So you can see what is the space h. So what is x n mean? Because n is 1, degree 1. So what is this become? X1 minus x naught taxim by 1. So it's straightforward. This is your what? 2, and this is what? The 3. And h is what? 0. H is a 0.1. No, sorry, 1. But if we have the same interval and we need what? Degree 2. How many points we need for this case, please? We need 3 points, I'm right?
Yes.
Yes, right.
We need, so x2, we need 3 points here. How to select 3 points? We are given interval is 2 and 3. 2 is the first point, 3 is the last point. So this is we know already 2. This is we know already 3. The middle one we have to know what is that one. And this we will have to calculate this one. So what is your h? The final point, which is 3, minus initial point, which is 2, taxim by n. What is degree 2? N is 2. So we have 3 minus 2 taxim by 2, which is half. So this means this will be what? 2.5.
Sorry, Doctor.
Yes.
How we decide the number of n?
Number n.
Yes.
This is the one. The formula, let's have start again now. We have the formula to find h. What is h? H is the distance between the points, and point should be the equally spaced here. So it means you should have only one value of h. Formula is what? The final point minus initial point taxim by n. N mean the degree of the polynomial in this case. For example, for this interval 2 and 3, and we need the degree 1. Degree 1 mean n is 1. So you have x1 minus x0 taqseem by 1. So which we have is a 1. So you have the straightforward this one. For degree 2, we need 3 points. We know the first point is 2 and the final point is 3. So we need the middle point. So what we can have, we use this formula, n is 2 now. Okay. So we have final point is 3, initial point is 2, taqseem by n. N is the degree of the polynomial, and degree of polynomial is what? 2. So it's mean 3 minus 2 taqseem by 2, which become half, 0.5, and that's the things we have here now. Now please, any student give me, if we need degree 2. No, not 2, sorry. Degree 3. How many points we need, please?
2.
Uh-huh.
4. 2 points.
4.
Okay.
Right? We need 4 points. We need 4 points. Our interval is given what? 2 and 3. So we already know what is the value of x0. Is 2.
2.
And what is x3?
3.
So we need to find
3, yes.
the x1 and x2. And how to find xn and 2 should be the equally spaced. So we need h. What is the h formula here?
3 minus 2 over 4.
3 minus
2 over 4.
2 over
4.
uh-huh.
3 over 3.
Yeah, over 3. Degree 3. So what is the jawab? 1 by 3. So you can have 2 plus 1 by 3. How much? 2 plus 1 by 3 is what? 5 by 3. Can you see how much? 2 plus 1 by 3. Let's I do here. 2 plus 1 by 3. How much is? 7 by 3, right? Sorry. Is 7 by the 3. Seven by 3. And then what is x2? 7 by 3 plus 1 by 3. How much? 8 by 3. And if you continue like this one, this is what? 8 by 3 plus 1 by 3 equal to what?
3.
Yes, is the final point we already have here now. So this is how can you find out the middle point. And one question definitely come in the exam. If we say equally spaced, use Lagrange formula for equally spaced. Teacher never give you the point. He only give you the degree and only the interval. Let's say he give you this one, same point, sorry, interval, and he say what? He say degree 4. So degree 4, how many points we need?
Five.
We need 5 points. X4, and this is right. And we know the first point, because interval is given 2 and 3, the first point is 2 and final point is what? The 3. The middle point we have to find out. And how to find the middle point? We have this formula. 3 minus 2 taqseem by degree. Degree is your 4. So this is 4. And this become what? This become 1 by 4, which means 0.25. So what is your x1? Any student? What is your x1?
2.25.
2.25.
Yes.
What is this one? 2.3.
2.5. 3.
2.5, and this is what?
2.75. X3.
2.75, and 2.75 plus 0.25 is what? 3. So that's the things. How can you find the middle point, right? So please, this is an important formula. You have to remember that one here. Let's say here, and I give you here, what is the, for example, what is the error bound of? What is the error bound of degree 2? This is the error bound. Now I give you for equally space, directly you know the formula. If teacher say find the error bound for degree 1, so this is you have to memorize here. This is the error bound formula for degree 1, only for equally space I'm talking about. This is a formula of the error bound for the quadratic Lagrange formula for equally space, and this is a formula for degree 3. Generally in exam, degree 3 or 2 given here, and this is a generalized formula for that case here. So this is, please, very, very good formula generally give, and I give this example last time. This is very simple, no need. Yeah, this is a very good example, please. And what does he say? He say find or determine, same thing. Find the best possible value of h to construct the table for this one. Because he give you what? He only give you the interval. So interval mean you are given the initial point and the final point. Middle point we don't know unless we need to find out the h. He say, the first part he say, find h and then create the table. This is and how to find h, we should know some formula. And he say use the error formula for the linear Lagrange interpolation with the accuracy 9 multiplied by 10 minus 2. This is the first part. Construct the table with the help of error bound formula of the linear Lagrange and with the accuracy this one. Then he say after you find the formula, construct the table, use a constructed table, find the approximation of f2.6 using the linear Lagrange polynomial. That's the things we have here now. Then he say compute the absolute error. This is the easy things here. Now, first thing you have to know, what is the error formula for the linear case? This is the formula for the linear case. And what is the accuracy given? Accuracy is given this one. We need to find h. So what you have to do here now, please, you need to calculate what is the unknown only here. We need to find h. We should know m. M is what? For the linear case, what is m? The maximum value of the second derivative. So you have to find out, this is the first derivative of the given function. This is the second derivative of the given function. And then you need to find the maximum value of the derivative of the function at this one here. As I told you, when you have the function power, if you take this one up, its power is a negative. When function power is negative, maximum always majud at the smallest point, 2. So we have 1 over 2 plus 1, 3 power 2 is a 9. This is the maximum value here. Put the value of m is 1 over 9. Simplify h square, you will get this one. And take the square root because we need h. And when you take the square root, you have h is equal to 0.25. Now you have 0.25. The first point is given 2. Second point, final point is given 3. And you have to create the x value with this h, which is this one, 2.525. This This is the things you have here. So this is the first thing. He say find h, and h will give you how many points we need here, and then you create the table. So first he say create the table, and you have to create the table here. What is next job? He say after you create the table, find the approximation of two function at 2.6, use a linear Lagrange. And the linear Lagrange need how many points? Is a 2 point. So we have to select 2 point from here. With x is given what? 2.6. What is the 2 point you will choose, please? X is given 2.6. So what is the best point you will choose for x0 and x1? Please, anyone? What is x0? Should be. From the table, please, you have everything in front of you.
2.
Allah, Allah, you have to select. Half of the chapter is finished now. You have to select such 2 points which is close each other and 2.6 inside.
2.5 doctor and 2.75.
Yeah, that's the things you don't. Half of the chapter is finished now. How to select the best point? 2.7. This is the best point because these are the close each other and 2.6 is this one. Yes, if you choose 2 and you choose 3, interpolation majud, because 2.6 is between them, but you have a very bad approximation. To get the good approximation, size of the interval should be as small as possible and interpolating point should be inside. That's the things 2 point you choose here for this edge. So that's how I say you use this x and that one here. And then you use a linear Lagrange formula. This is the linear Lagrange formula. And when you use this one, you have, this is the approximation. That's a very good example, please, we have here from exam point of view. Then he say absolute error and absolute error. I have some mistake here, but I already corrected in my book, and I will send you the inshallah corrected one here, because f of 2 point, this is the thing. See, your x is what? 2.6. So 2.6, what is your function? Is 2.6 plus ln 2.6 plus 1, which is what? 2.6 plus 1 is a 3.7. Is anyone has a calculator? Let me check. What is the 3.7? Ln 3.7, please. Ln 3.7. You understand it? This is 2.6. This is 2.6 plus 1. So 2.6 plus 1 is a 3.6, sorry. So we have ln 3.6. This is equal to 1.28. 1.28. Right? So this is mistake. Yep. Please, I already corrected in that one here, right? So please forget. I will send you the file which must be corrected already here, because this should be what? This should be 3.28, right? So this is the things you can have. This is the wrong value, but this value is a good one here. Now, why we have this value? Because when I give this problem in exam, I give this one, same thing. Find the value of h with the help of error formula of the linear case. Here, I say when you construct the table, you have this table now, please. You have this table. Then I say, here my question change in the exam. Then I say use constructed table to find approximation of 2.6 using quadratic linear polynomial. And the quadratic linear polynomial need how many points, please?
3.
The 3. Okay. So which point you will choose now, please? Okay, now just tell me.
.5 and 2.75 and 3.
What about 2.25, 2.5, and 2.75? You cannot use that one.
You can use it also.
What is the distance, please, in that case, if you choose this one? What is the size of the interval?
It's all the same. 0.7.
0.25.
Don't know. 2.25 to 2.75. How many distance you have?
No, this half.
Half. And 2.5 and 3 is what?
Also half.
Half. So we can have a chance. Either we use this or this one. Exactly the same here. But of course, in exam, when teacher give you in exam, generally he never give you the two interval. He always give you one possible interval which you can use here. But you understand my question, please, okay? So this is a way how can you have the problem in exam. This we finish. This is example 2, 3 times I give in the exam. And first time when I give in the exam, I have a small mistake. And let me check my mistake. You will catch it or not. I have this example. He said let f of x is equal to x plus 1 ln x plus 1 with a function defined in the interval. And then I say find the approximation of 2.9 ln 2.9 using linear, quadratic, cubic for the equally spaced data point inside that. Of course, here I'm just doing this one. But in exam, of course, I will not give you the linear, quadratic, and a cubic. In exam, I give you only one, either linear or quadratic. And also, as I told you, cubic I cannot give you. Cubic will be the length. Okay. Now, first of all, I give you what I give the first time in mistake in the things here. I give in the problem in the exam. I say, this is my function, this is my interval, and I say, find the approximation of 1.9 ln 1.9. 1.9 ln 1.9. And this is a big mistake. Can any student give me, what is the mistake here? If I put 1.9 and ln 1.9.
0.9 is not in the interval.
Yes, this is the only things here. What is your x?
0.9.
X is a 0.9 and 0.9 is not this one. This is the things here. And when the 0.9 is not inside, this is not interpolation. So it means therefore I make sorry in the exam and I say change into 2. And when we have this one, what is your x? What is your x here?
Here 1.9.
1.9, and alhamdulillah 1.9 has no problem here, right? This is, you have to be very careful, please. Then he say compute the error bond for each case. Then he say compute the h and the number of points, all this one here. So let's see what we do here now. I do the case only 1, and the same way you can do the case 2. Let's say I do the case 1 here. For linear, how many points you need? The 2 points. And the 2 point always is the end point of the interval. This is your x0. This is your x1, because your linear degree is 1. So h always equal to this one. So this is the things. So it means your x0 is 1 and x2 is the 2. And what is your x given? 1.9. So you need to find out L0, and you need to find L1, and you can see L0 plus L1 is equal to 1. Should be 1. If not, then you have to recheck. So then you have what? F of x0. What is f of x0? F of x0 mean f of 1. And how can you find f of 1? Your function is given. F of 1 is what? 2 into ln 2. 2 into ln 2. When you do, inshallah, you will get that. This is f of x0. What is f of x1? f of x1 is f of 2. What is f of 2? 3 into ln 3, and then you do, inshallah, you will get, this is the US. And for this case, you use this one and you have, inshallah, you will get this one. Now, for the case of the quadratic polynomial, what is your H formula? Is the final point minus first point taxim by the degree. And degree is what? 2. So you have, so it's a 0.15. So it means your x0 is 1, your x1 is 1.5, your x2 is a 2, and you have a 3 point here. And now you can use 3 point, and inshallah you simplify after finding this one, and you have this approximation. And for cubic degree, you need 4 point. So how to find h? Final point minus first point taxim by the degree, which is 3. So you have a 1 by 3. Then you can easily find out the formula is this is your 4 point, and x given 1.9 majud inside, and you use the formula, and this is the jawab you have. This is the first part. And then he say compute the error bond. We know what is the error bond formula of linear for the equal space, mh square by 2. What is the h in the case of linear case, please? We already calculated. This is a h in the linear case. What is this one? 1. So you can put here 1 power 2 is a 1 over 8 into m. M is the maximum value of the second derivative. And what is the maximum value of the second derivative is half. You can use this one, and this is the error bond formula of that. And the same way you can find the error bond formula for degree 2. What is h in the case of degree 2? You already calculated. What is the h in degree 2? Degree 2 h is what? Is a 0.5. And then you put here 0.5 here, which is half power 3. M you have to calculate. And what is m? Is the maximum value of the third derivative inside the interval. Interval is your 1 and 2, and then you can have this one, and then you can have for degree 3, and this is the jawab we have there. You can easily find the error bond, the maximum value, and this one. This is a absolute error for degree 1, degree 2, and degree 3. But as I told you, in exam, teacher only give you one, either degree 2 or 1 for the approximation. And what is the next part? He say use the formula and find the number of points. You have to do here sometime. What is the formula? As I told you, H formula is what? The final point, which we call B. Initial point we call A, taxim by the n. N is called degree of the polynomial. In this question, I say find the number of points. So what is the formula for number of points? Remember always, please. Number of points always equal to n plus the 1. So what you have here now, you use this error formula for degree 1. You calculate h, because accuracy given 10 minus 6, this one. You find h. When you have h is equal to this one, you can easily find out n, because we know what is the formula of n. N is equal to what? B minus A taxim by what? By h. This n I take up, and h I take in the denominator. Same thing. You know the h. And when you have h equal to this one, then you can have the value of n. N is what? 1, 1, 3. So how many number of points you have? 114, the number of points. And the same way you can do, please, for the case of. This is a very good example from examination point of view we have here. So we finish half of the chapter and we finish the first numerical method to find the approximation of the function at the given point, and that is called the Lagrange interpolation formula. The second one we will discuss inshallah next time, and that is called the Newton one here. The Lagrange and Newton formula exactly the same. If you find any problem solution with the help of Lagrange and the Newton, you are exactly same job up to every digits, no change, because they are exactly the same. Only way of writing is a different. Now, if your question is if they are same, why we need this one? Remember, as I told you, what is the big problem in the Newton, in the Lagrange formula? The big problem in the Lagrange formula is if you have a data point is large, then it's difficult from timing point of view. Because I never give you any example of the Lagrange case for degree 3, 4. Because for degree 3, we need more time here. This is the one point, the difficulty of the using Lagrange formula, that using Lagrange formula for higher degree, it becoming the timing problem. We need a lot of computation we have to do. This is one problem. The second problem is sometime we know what is the jawab of degree 2. We know the jawab of degree 2, but we cannot use the jawab of this one when we need to calculate degree 3. Because for degree 2, we cannot use in degree 3 because they are totally different. What we do here in this case, this is a good point of the Newton method. The good point of the Newton method is we don't care about how many data points we have. Here, inshallah, I will give you the example. I will find the approximation of the function for degree 5, 6 here. And the good point of this one is if we know information of P2, we can use in P3 the plus one small extra term. That's we have. This is given by the teacher. Only you have to calculate this small things. If you know the information of P3, we can use in P4 to calculate this one. Plus one extra term. This is the things we have here now. Therefore, as I told you, in this case, we can use the higher because in exam teacher say, find the approximation of the function at degree 5. When he say degree 5, he already provide you the jawab of degree 4. So you put degree 5 is equal to degree 4 plus extra term. Degree 4, you already know the jawab, only extra term you have. This is a beauty we will do in the case of the Newton formula. Right? We do inshallah later on this one next time. Any question you have, please? Before I take the attendance.
Everything is clear, inshallah.
Okay, alhamdulillah. So we meet next week. Special day next week on Tuesday. We will meet inshallah. I forgot to send you your room number, but inshallah, I will send you today. Inshallah, I will send you today.